Today we will discuss some basics about rotational motion. It is required for rigid body motions robotics, modern robotics. Observe the figure. Suppose a particle is performing circular motion with center at origin on this path. At certain instant it is at P. After a short while it is at Q. In time delta t interval it goes to here. So angle covered is delta theta by delta t. So average angular velocity is delta theta by delta t. We want to find instantaneous angular velocity at P. So we have to take limit delta t tends to 0, delta theta by delta t at location P, that is d theta by dt. It gives instantaneous angular speed or angular velocity. Average speed, so in that time interval the distance covered by particle is arc length. So average speed is length of arc pq by delta t, because of we have to consider distance, not displacement. This is speed. So r delta theta, arc length, r delta theta by delta t. Delta theta by delta t is average omega. So average speed is r average omega. But for instantaneous, v is r omega. Now we want to find the vector relation between v, r and omega. Observe this figure. Suppose the particle is performing circular motion this way, anti-clockwise. At certain instant it is at P and velocity is in the direction of tangent. This is the position vector r. So v is omega r, but we want omega cross r. Here omega is coming out of the plane of board. So omega this and v this. This one is omega, this one is v. So omega cross v towards center. Omega cross v. Sorry. Omega this one and this one r. So omega cross v, omega cross r, it gives velocity v. So v must be omega cross r according to direction. Differentiating with respect to time t, dv by dt, we have to use product rule. Omega cross dr by dt plus d omega by dt cross r. Order is very important. So linear acceleration is omega cross v, dr by dt is v, initial velocity, and d omega by dt is alpha, angular acceleration, cross r. So omega cross v is radial acceleration. This one, and this one is omega, this one is v, this one is omega, this one is v. So omega cross v, direction towards center. So it is radial acceleration, centripetal acceleration. What about alpha? Suppose the particle performing circular motion with increasing speed. So delta omega is coming out of the plane of board. So alpha is this and r is this at point P. This one is alpha, this one is r. So alpha cross r, it is in the direction of v. It is called tangential acceleration, AT. If the particle is performing circular motion anti-clockwise with increasing speed this way, then acceleration at certain instant, suppose particle P is here. So acceleration is not towards center, actual acceleration. It is at some angle. It has two components. This one is radial acceleration, this one gives tensile acceleration. Radial acceleration is responsible for circular motion and tangential acceleration is responsible for increasing speed. If the particle is performing circular motion anti-clockwise with decreasing speed, this way, decreasing speed, then at certain instant at location P, acceleration is this way. It has two components. Particle is going this way, but acceleration is this way. It has two components, AR and AT. AR is responsible for circular motion. AT is against velocity because velocity is in this direction. It is opposite to that of. So it is responsible for decreasing speed. For this, do you know what is radial measure of an angle? So for circle, if you move from this point to this point, the corresponding angle is 360 degree. So corresponding arc length is 2 pi r. Then for theta degree, how much arc length? So arc length is pi r theta upon 180. Consider this figure. theta degree, this one radius r, this one radius r dash, bigger radius r dash. So for this L by r and for this L dash by r dash, ratio remains same because of angle is same. What is L? L is pi r theta degree upon 180 divided by r cut out. So it does not depend on L as well as r. The ratio remains same for given particular angle. So theta radian is pi theta degree upon 180. Okay.